video lesson, or just this lesson to wrap up this week, we are going to continue simplifying algebraic expressions by combining our like terms, okay? So just remember the definition, or what's the difference between a numerical expression and an algebraic expression. Algebraic keyword is that we will see some variables in that expression, okay? So now, what do I mean by combining like terms? If you think of what we did on Monday, when you combine like terms, you are combining, or what like terms are is that like terms are variables that are the same, or are terms that have the same variables raised to the same power or exponent, okay? So if you think of this, we have 4x squared. You can say this is read as 4 times x to the second power, or 4x squared. Notice that I have my variable x, and I have a power of 2, okay? So in this case, x squared would also be a like term with 4x squared. Now the reason why I put x squared is because, remember, if you don't have a number in front of your variable, it is always going to be 1. Your coefficient is always going to be 1, okay? So again, these two are like terms, and again, they are like terms because they have the same variable, which is x, and they are both raised to the second power, or they have the same exponent, which in this case is 2, okay? X squared and x are unlike terms, okay? Yes, they have the same variable, but notice how they do not have the same power, okay? So my first term is x squared. Remember, if you don't have a number in front of it, it's always going to be 1. And then my next term is just x. Again, they have the same variable, but they don't have the same powers. This first term right here, the power is 2. This second term right here, the power is just 1. So again, we would say that these are unlike terms. Okay, here is just a drawing or an example or a chart of what like terms are and unlike terms are, okay? So if we look at the first row, and I'm going to try to use my laser printer, notice how I have both variables to the first power, okay? Both of these variables are x, and they're taken to the first power. This second column right here, I have 2x and 19a. They are not the same variable, okay? And again, you want to kind of just look at what I mean, or this chart right here, because when you're able to compare what's considered as a like term or an unlike term, you can see like the different patterns, okay? So like if you look at this one right here, it says 32a squared plus 9a to the third power. Yes, we have the variable a, but notice how I have different powers. And again, you want to make sure that they have the same power. Okay, so let's go ahead and do some practice here. For each pair of items, indicate whether they are like terms or unlike terms. Okay, so again, you want to identify if they're like terms or unlike terms. Okay, so I'm going to do 1 through 10 with you, and you are going to do 11 through 20 with you. Okay, so looking at number 1, again, I have two variables that are the same, which in this case is x, and my exponents are also the same. So because they're the same, I'm going to say that they're like terms. Okay. Number 2, I have again two variables that are the same. Remember that when you don't have an exponent, you always assume, or if you don't see an exponent, that exponent is just basically 1. Okay, so in this case, both of my exponents are 1. Both of the variables are the same letter, so I would say that this is like terms. Okay, number 3, I have b as my variable, but notice how one of my variable has an exponent of 2, and then the other one has an exponent of 1. So again, although they have the same variable, but they don't have the same exponents, we would say they are unlike terms. Okay, number 4, it's obvious. I have two different variables. In this case, two different variables just mean that they're unlike terms. Okay, Number 5, I have negative 2x and 7x. In this case, I have two variables that are that are the same letters, and they have the same exponent, which in this case is 1, so they would be like terms. Okay, number 6, I have one term that has a variable and another term that's a constant. Remember, using vocabulary words, constants are terms without variables. So because I don't have a variable here, I'm just going to say that this is an unlike term. Okay. Number 7, I have two terms. My first term is g to the second power. My second term is g squared, or g to the second power times h times I. These are two terms. They are considered as unlike terms because if you look at my first term, I only have the variable g. If you look at my second term, I have the variable g, h, and I. Okay. Number 8, I have two variables in both terms. My first term is 2x squared y. My second term is 8x squared y. Both of these terms have the same two variables to the same power. So both of them have x to the second power as a variable and y to the first power as a variable. So we would say that they are like terms. Okay. Number 9, be careful with number 9. Even though they have the same variable, again, they do not have the same exponents. Okay, one exponent is 1, the other exponent is 2. So again, I'm going to say that this is unlike terms. Okay, and then last but not least, just be careful with number 10. Yes, we have the same variables. Both of those variables are x and y on both terms. Okay, so again, I have x and y on this term, and then I also have x and y on this term. But again, just be careful with the exponents. They're not the same. You have x to the second power for the first term, and then you have x to the first power on the second term. So that just tells me that they are unlike terms, okay? So now what I want you to do is I want you to go ahead and pause this video, and I want you to just go ahead and try 11 through 20 on your own, okay? Again, you want to try it on your own. You don't have to write it down, but kind of just state it in your head. Number 11, are they like or unlike terms? And then when you're done with that, I want you to check your work. So right now, use this time to pause the video and kind of do these problems on your own. Okay, now here are the solutions. I hope you're able to check your work to see if you did it correctly. If you did it incorrectly, please identify or try to find a reason to why you did it wrong. Okay? All right, the next examples that I want to do with us is going to continue with what we did on Monday. What we're going to do is we're going to simplify each expression by combining like terms, okay? So I was only able to do about 3 examples with you guys for class on Monday, but here are, before we do this, I'm sorry, just remember and as a reminder to write your answer with the terms with the largest degree to the smallest, okay? So I want you to think of what we did on Monday and how we practiced rearranging those terms, where my first term started off with the highest degree and then it decreased each term. Okay, so I'm going to do the first 8 problems with you, and then to wrap up the class, you guys are going to do 29 through 35 on your own. Okay, so looking at 21, I have 2 terms that I want to add. Remember, terms are separated by either an addition sign or a subtraction sign. So again, revisiting concepts in math, I have 2 terms that I'm trying to add. Now, in order for you to add the terms, and I know I'm adding it because of this addition symbol, in order for you to add the term, they have to have like terms, okay? So in this case, I do have 2 terms that are like, okay? They both have x to the second power as a variable and y to the first power as a variable. So when your terms are like terms, all you want to do is focus on your coefficients. Remember, coefficients are your numbers in front of your variables. In this case, my coefficient is 3 and 4. It tells me, or this operation right here tells me to add the 2 terms. So 3 plus 4 is, wow, I wrote 9. Okay, 3 plus 4 is actually 7. Okay, and when you, I'm sorry. Okay, when you combine your coefficients, all you have to do now is include your like terms. So this would be your final answer. Okay. Number 22, you have, again, we're adding two terms. Your first term is 3b. Your second term, remember what that coefficient is? That coefficient is going to be 1. Okay, so your second term is 1b. Now, if you look at this, both of these terms are the same because they have the same variable to the same power. My variable is b, and they're both to the first power. So all you have to do is, again, focus on your coefficients, which means 3 plus 1 is 4, and then just include your like term, which is the variable in this case, and your final answer is just going to be 4b. Okay, next, 23. Now, if you look at 23, I have a total of 3 terms. Okay, so again, I'm just revisiting some concepts with you. I have 1a as my first term, I have negative 7a as my second term, and I have a positive 3. Okay, you are combining them, so in order for you to combine them, they have to have the same variables to the same power. Okay, so if you look at the first two terms, or just remember that a is also known as 1a. Now, if you look at the first two terms, notice how the first two terms have the same variable to the same power. Those two are like terms. So because they're like terms, again, I just want to focus on my coefficient. And what I'm going to do is I'm going to pull out my calculator, and I'm just going to enter in 1 minus 7. 1 minus 7 is a negative 6. And again, don't forget about that variable. Okay, so again, 1a minus 7a is negative 6a. And then you cannot add 3 to negative 6a because 3 is a constant. 3 is a term without a variable. So notice how I just have plus 3 left. I'm going to go ahead and bring that into my final answer. And this is your final answer. Okay, now just get into the habit of always writing your terms with your variables first. Okay, so notice between negative 6a and 3, the term with the variable is negative 6a. I'm going to write that first because it goes back to this. You always want to write your terms with the largest degree. So in this case, my degree is 1 to the smallest. Okay, let's go ahead and look at number 24. I have 14ab plus ab squared plus 2ab plus 3. Okay, remember 14ab is just basically 14 times a times b plus a times b squared plus 2 times a times b. Okay, again, I have a total of 4 terms. My first term is 14ab. My second term is ab squared. My third term is 2ab. And my fourth term is 3. Okay, you want to combine your like terms. So in order for you to combine your like terms, you have to identify the terms where they have the same exact variables to the same exact powers. Okay, be careful with this because I can see where common errors or common mistakes that you make. Notice how these first two terms that I just highlighted, notice how they both have the variable ab. Okay, however, just be careful because this middle term right here has b to the second power, while these other two terms that are highlighted just has b to the first power. Okay, so these two terms right here, what you want to do is you want to go ahead and combine them. And the reason why you're combining them is because they are like terms. Now, before you start that, there is no term that I can combine with ab squared. So what I'm going to do is I'm going to go ahead and move ab squared and write that as part of my final answer. And the reason why is because, again, you want to write your terms with the largest degree to the smallest. Well, ab squared has the largest degree, so I'm going to go ahead and write ab squared first. Next, I'm going to combine 14ab and 2ab. They have the same variable, and then I'm going to add 14 and 2, which gives me 16ab. And then notice there's nothing that I can combine with 3. So I'm going to go ahead and bring that plus 3, and this is my final answer. Okay, so I would box this. Okay. 25, if you look at 25, again, I have 3 terms. Remember that this is a 1 in front of this variable x squared. I'm going to combine 1x squared with negative 3x squared. So you can think of this as 1 minus 3 or 1 and a negative 3. They mean the same thing, okay? Again, the variables are the same with the same exponents. Again, they're like terms. 1 minus 3 is a negative 2. And then all I have left is this plus 7. Don't forget about this plus 7. So this is your final answer. Again, I cannot add 7 and negative 2x squared. And the reason why I cannot add that is because 7 is a constant, while this term right here has a variable. Okay? Number 6, I have a total of 3 terms. Okay? And again, notice these terms right here. I have, they're all the same variables to the same power. So because of that, I'm going to go ahead and just add all 3 terms by focusing on their coefficients. 1 plus 2 is 3. 3 plus 1 is 4. So you have 4ab as your final answer. Okay. Almost done here, because again, you're going to try 29 through 35 on your own, okay? So 27, a very confusing problem, or not confusing, but I can see where some of you may make some mistakes, okay? So again, 4 terms right here, okay? And again, you want to combine your like terms. If I look at this term right here, and I'm just going to highlight this, and this term right here, notice how they have the same degree, and I'm sorry, the same variable to the first power. So in this case, these 2 terms are like terms, so I'm going to go ahead and add them. And if I add 7g and 7g, I get 14g. And then I can also add 7gh and 7gh. That's going to give me a positive 14gh. Okay, and that would be your final answer. Okay. Number 28, I want you to go ahead and just pause this right here and try this problem on your own. As you're doing it, or just when you're done with it, continue on with the video, and then you will check your work, okay? Just remember that as you're doing this, you want to write your answer where you list the largest degree first to the smallest.
Can you do it?
Okay, so make sure you check your work for problem number 28, okay, and see what, if you did it wrong, see what mistakes you made, and if you did it correctly, a pat on your back, okay? Looking at the next problems, I want you to try 29 through 35 on your own. And what you're going to do is you're going to go ahead and hit pause. And then when you're ready, just continue the video to see if you did your solutions correctly. Okay, so right now just use this time to check your work and see any mistakes that you made. Okay. Alright, so to wrap up this lesson, I have 2 problems that I want you to do. Just remember that the goal is for you to pass the HiSET test. And if you think of it, it's pretty much multiple choice for the most part. So this is good practice. Number 36, it says, what is the simplified form of the expression 3a squared b plus 4ab plus 3a squared b plus 5ab? So the approach to this is, again, combining your like terms. I'm going to go ahead and combine 3a squared b and 3a squared b. because again, they have like terms. So when they have like terms, I'm just going to add my coefficients, or in this case, add my coefficient because it says plus. Okay, so 3 plus b is 6ab squared, or 6a squared b. And then I have 4ab that I'm also going to add with 5ab. 4ab plus 5ab is going to give me 9ab. So your final answer is going to be B. Okay, 37, when simplified, how many terms are in the polynomial? So you have j squared plus k cubed minus 2j cubed plus 5k cubed minus 2j squared, okay? So I have, and I'm going to go to my laser, or you know what, yeah, I'm going to try to go to my laser. You'll see that we have 1, 2, 3, 4, 5 total terms, and I'm going to start combining my like terms. First off, if I just look at my exponents, you want to get into the habit of identifying your highest exponents, okay? So in this case, I know that k cubed and negative 2j cubed, or just the third power, is my highest exponent. Now what I'm going to do is I want to start off with, again, when you write your expressions, you always want to start off with your highest power, which in this case, we're going to start off with 3. But notice how I have two different variables. I have j and I have k. Okay, now my approach to this is to always just think of your alphabet. What comes first before j and k? Obviously, j comes first, so that's going to be my first variable. Okay, and the reason why I'm comparing my variables is because I have two variables whose terms are to the third power. So if I look at negative 2j to the third power, there is no terms that I can combine with that. So I'm going to go ahead and bring that down. Okay, and then again, just keep in mind, I always kind of just cross out the terms that I quote unquote combined already. Next, I'm going to go ahead and combine 1k cubed and 5k cubed. That's going to give me 6k cubed, because again, you want to start listing them from your highest degree to the lowest degree. In this case, we're still focusing on our third degrees. After we finish with our third degrees, I'm going to go ahead and look at my second degrees, which in this case, what I have left over is 1j squared and negative 2j squared. That's going to give me a negative j squared, okay, or negative 1j squared. Now, if you look at this problem, it's asking us how many terms are in the polynomial. So when I simplify this polynomial, I have a total of 3 terms, so your final answer is B. Okay, so I hope this was a good lesson. You know, if you like the recorded videos, please let me know, because this is, I think it's good to kind of switch around. So, you know, have those live lessons as well as these recorded lessons. I know my students prefer these because they like to pause them. Okay, so if you don't have it, so what I'm going to do is I'm going to wrap up the lesson here. I know that you guys have been asking or been probably considering like why I haven't assigned you any essentials assignments yet. I hope you're still doing those on you know, according to your level and watching those videos. But know that I really want to try to get into some more algebraic stuff before I can start assigning lessons. Okay, so we do have about like 2 more things that I still want to go over with, and then hopefully we can start doing essentials. Again, because just keep in mind that although I'm not assigning you any assignments, you should still be doing math problems, okay? Because your goal is to, again, improve. Okay, let me know if you have any questions.